Hi, welcome back. In the previous lesson, we used a case for difference in population means when population standard deviations are known. In this lesson, we are going to use two cases, one for difference in population means when population standard deviations are unknown and believed to be equal, and next case was about difference in two population means when population standard deviations are unknown and not equal. So, case 2 is all about this difference in two population means when population standard deviations are unknown. That means in case instead of having the data on population standard deviations, we will be given the values of sample standard deviations. Okay. So this is the case that we are going to handle. Okay. So a company makes a claim that the children in the age group between 7 and 12 who drink their health drinks will grow taller than the children who do not drink health drinks. This is the claim. That means the claim is greater than. Grow taller means it is greater than. Claim is greater than. The claim questions the theory. What is the theory? The theory is less than. That means when we frame null hypothesis, it has to be less than or equal to. When we frame alternative hypothesis, it has to be greater than. This is the implication that we can get or extract here. Okay. The table shows. Okay. The table shows uh, that average increase in height over 1 year period between two groups. Two groups are taken here. This is mu1, this is mu2. Okay. So they group 1 drinks health drinks, and in case of group 2 they don't that drink health drinks. This is the sample size. This is the sample size. Sample size for both the group is 80 and 80. This is the increase in height during. This is the sample standard deviations. Sorry, this is the sample mean. Okay, this is the sample mean. For group 1, this is for group 2. This is the sample standard deviation for group 1 and group 2 we have been given. So here it has been given. So let us see one more line. At alpha of 0.05. So 0.05 is the level of significance. Test whether the increase in height for the children who drink the health drink is at least 1.2 cm. That means this is that what we have been given. That means it has to be mu1 minus mu2 equal to, this is the difference. The difference, this it is increase in heights for the children who drink the health drinks is at least 1.2 cm. So mu1 minus mu2, you can call it difference between two population means equal to 1.2 cm. Okay. So this is what is given. So this is we have derived from this table. This is the data that we have been given. This is x1 bar, this is x1 bar, this is x2 bar. These are there here. Okay, we have got it. So these are the data that we have taken, and we have sample standard deviation we have been given 1.1 cm, and for second group it is 1.3 cm we have been given here. Okay, we have been given here. This is data we have been given here. Okay. So null hypothesis can be framed like this. So the claim is greater than. Okay, the claim is greater than. So therefore we have here like claim is, this is, we have got claim is greater than. This is the alternative hypothesis we have got it. Okay, alternative hypothesis 1.2. So this is less than. Okay, this is just the opposite. The claim is taken at the alternative. So this is at the alternative, that is right tell, it tells. Okay, so this is the formula. Okay, T equal to x1 bar minus x2 bar minus mu1 minus mu2. We have been given mu1 mu2 as this. Okay, so then this is sp square. Sp square means pooled variance. Okay, this is sp square into 1 by n1, that is the number of samples for group 1, plus n by n2, number of sample for group 2. So this SP2 is called the weighted average variance of two samples. Okay, this is required. This is called pooled variance. Okay, when in this case we have to find out this. So then SP square, how it is calculated? It is calculated as, this is S1 square. S1 square means it is standard group 1 sample 1 standard deviation square minus, this is the degree of freedom for group 1. Degree of freedom is calculated as n minus 1. What is the n? N is 80. 80 minus 1, this has to be 79, plus similarly for group 2 it is S2 square, this is 1.3 square into, this is the degree of freedom, n2 minus 1, that is 79, divided by, this is the df. Df means two groups are there, that means 80 plus 80, this has to 160 minus 2 groups, that means 158. So we have what we have done, we have filled the values here. Okay, so these are, and finally we have got SP square was 1.56. Okay, then we have to calculate the t value. Okay, this is the t calculations we have to do t statistics, because t statistics we have to find out the t value, t starts value, then we can compare it with the t critical value to find out whether H0 or null hypothesis is accepted or rejected. So what we have done, we have put value here. Similarly, this is the formula that we have got. Okay, so this formula, that what we are going to do, we are going to fill the value here. So this is x1. What is the x1? X1 is, this is the x1 7.6 minus x2 6.3 minus mu1 minus mu2. This is the value, divided by SP square we have got. This is SP square we have got. SP square is this 1.15. This is 1 by n1. N1 is 80 plus 1 by 80. Okay. So this is how we can. So this is t statistics. Then what we can do? We have to find out the t critical. How to get t critical? We have to refer to the table value. Okay. This is one tail test, and this is one tail and right tail test, because you can see this is our null hypothesis direction. You can say this is the right direction. Therefore it is that is right tail test and one tail test. So for this we can see from t distributions, we can see there is a t distribution table. We have to find out the value of critical value of t critical. One tailed alpha, what is the alpha value? Alpha value is 1.05. The degree of freedom is 1.58. 1.58, how it is 1.58? So this is 80 plus 80. Okay, sample size is 160. 160 minus 2, because two group sample. Therefore, it is become 185. Okay, so this has become 1.65. How you can check this? This is the link that I have given. You can also check this. Let me show you how to check it. Okay, just a minute. Okay. So this is, we can see what we have been given. 158. This is t. You can see this is t. You can see t distribution table. I have just that link, that click on the link. So this is one tail. This is one tail 0.05. You can see this is 0.05. Then degree of freedom. This is degree of freedom 158. First column you are checking. We are checking 158. 158 is this. This is the figure that we are getting. Okay, 1.654. 1.654 we can see. Okay. So 1.654 we can see. So this is 1.654. Okay, T critical. T critical is 1.654. And what is the T? What we have got T calculated? We have got it as this. This is the T calculated. Okay. T calculated is this. So this is T calculated, means obviously it fell in the in the acceptance region, therefore we can call it that H0 is accepted. Here T starts or T calculated is lesser than or less than the T critical. So therefore what we are going to do, we are going to accept H0. Okay. This is a case that we have handled. Then we will handle another case. Let us review before that. We have uh, like one case we have drilled the two sample test difference in two population means when population standard deviations are known. So this is the formula, and in the case 2 that we have discussed, this difference in two population means when population standard deviations are unknown and believed to be equal. Okay, so this is the formula that these are the formulas that we have used to get the T critical. Then we are going to use another case that is called difference in two population means when population standard deviations are unknown. These are unknown and not equal. Okay, population standard deviations are unknown and not equal. Okay, this is the case. So a researcher is interested in finding the average duration of marriage based on educational qualifications of couples, whether education qualification is one of the significant indicators of the stability of married life that researcher wants to see. So there are two groups of couples that he has taken, and a group of couple that has at least no bachelor degree, and there are also another group he has taken that the married couples who have at least bachelor's degree or higher degree. Okay, there is a table data that has been given. You can see table data. So this is the sample size. It is given for both the group. So 120 and 100. This is the duration of marriage. Okay, duration of marriage. This is the sample. This is drawn from samples, and this is the sample standard deviations we have been given. Here population standard deviation is not given. We have been given population this sample standard deviations. Okay, so this is the data that we have been given. When in this case, when it is not given, mu1 and mu2 are not given, we have to assume that the difference is 0. Okay, difference is 0. There is no difference. So therefore, here x1 we have taken this x1, and this is 10.1. We have derived this from the table. Okay, we have derived from the table 10.1 x1, then x2 is 9.5, then this is the standard deviations for sample S1. Okay, in case of population it is sigma 1. Okay, here it is S1 S2. Okay, then this is the sample 1, this is sample 2. Okay, we have taken. Then this is the null hypothesis. Null hypothesis, since it is not given, the mu1 mu2 is not given, we will calculate it is at least greater than 0. This is the claim. What is the claim? Whether the average duration of marriage is more in couples with no bachelor. So claim is more in couple, therefore this is the direction, null hypothesis direction. Obviously this is the right tail test because this is one directional and in the right directional. Okay, so this is the alternative hypothesis is the this is the right directional. Okay, so obviously the opposite direction is equal to or less than. Okay, so this is the T calculations, x1 bar minus x2 bar minus mu1 minus mu2. Okay, when it is not given, we take it as 0. Okay, s then divided by s1 square by n1 plus s2 square divided by n2 root over. So we have filled the value here. Okay, we have taken x1 bar and x2 bar, we have taken this 2. Okay, then minus 0, we assume that this is 0, there is no difference. Then we have s, this is the value that we have taken from here. This is group 1 standard deviation of sample, this is group 2 standard deviation of samples, and this is the size of samples. And finally what we have got, so by filling up the data, we have got this is the T statistics. Okay, here what is more important, we have to calculate the degree of freedom. Okay, degree of freedom in this case, This is the formula, because when we don't have the data on mu1 and mu2, we have to calculate the degree of freedom based on the given data. Like if you see, it is like this is S1, this you can see we have brought it here. Okay, so this is the data that we have brought it, and then what we have done, S1 square by n1 whole square by n, this is the degree of freedom. So this is S2 S1 square. So this is the degree of freedom for 2. Okay, this is 2 actually. This is 2 actually. Okay, so we have been given, then we have put the data here. After that we have got it that 184 is the degree of freedom. So now we have got the T statistics, we have got the degree of freedom. Next step, that we have to find out what is the T critical. Then we can compare T critical with the T statistics to accept or reject the null hypothesis. Okay. So from the T distribution table for a right tail test and an alpha of 0.05, this is the level of significance, 184 degree of freedom, the T critical value is approximately 1.653. So we can check this also once again. This is a right tail test. Okay, so this is a right tail test. I will take you 184. Okay, 184. Okay, I will take you here 184 once again. See, this is once again one tail test. This is one tail test. This is 0.05. This is the alpha. Okay, so this is the degree of freedom 1.84. 1.84 degree of freedom is 1.64653. Okay, so then we can see. So this is what we have written here. Okay, then what we can see, we can plot it. Okay, this is the plotting that we have done. So this is the T critical. T critical, what we have got, it is this is T critical 1.1 this T critical 1.653. This is the T stats. That means ultimately it falls in the acceptance region. That means we are accepting null hypothesis. We are not accepting H1 or alternative hypothesis. Okay, this is how we can use data to that organize to conduct hypothesis test. Okay, so thank you very much. That's for the lessons. In the next lessons, I am going to use a paired sample t-test. Thank you.